So in the second video of this series, we're going to be looking at another linear application systems problem. This is one of those problems that I often think about showing up on the SAT or the ACT or any type of standardized test. And it really kind of reads like a riddle, but the more we think about it, it's just a linear system. So here it says, twice John's age plus 5 times Claire's age is 204. 9 times John age minus 3 times Claire age is also 204. How old are John and Claire? So notice that we actually only have two variables. We only have how old is John and how old is Claire. And we have two different situations where we can set up a formula. So these problems might not always read like this. Sometimes it's like Claire is 5 years younger than John. Sometimes it'll say something like that, but that's still just a system that, or an equation that you can write that is going to get you to a system. So let's go ahead and start writing these. I'm going to use J for John and C for Claire. And now I can go ahead and so it says twice John's age. So 2 times J plus 5 times Claire. So 5C is equal to 204. Then I have 9 times John's age. So 9J minus 3C is also 204. Now, the fact that they're both 204 might make you think that you've done something wrong, but if you read the problem, that's just the information. They're probably trying to trip me up, but that's okay. We can go ahead and solve this. So now with this system, they're not both set equal. In the last video, they're both set equal to C. That's not the case here. So I need to determine, can I use substitution or should I use elimination? And honestly, you could use either method, but typically one of them is going to be slightly easier. So as I look at this, I ask myself, can I multiply something like an integer by 2 and turn it into 9? And the answer is not easily. And so I'm going to ask the same thing about C. Can I multiply 5 or 3 by an integer and turn it into the other one? And the answer again is, well, not easily. So instead, I'm going to try substitution. I'm going to try and see if I could easily isolate one of these. So if I try to isolate J, that means I'm going to multiply 5 and 204 by 2. 5 doesn't easily divide by 2, so probably not there. Looking at the second one, I would probably want to isolate C because it has the smallest coefficient. I know that 9 divides by 3, so that's cool. I'm going to really check on my calculator if 204 divides by 3, and it does. So that is why I personally am going to use substitution. You can do this with a different method. That's just my choice here. So I'm going to take this and I'm going to isolate the C, Claire. I'm going to start doing that by subtracting J to the other side. Try that again. Equals negative 9J plus that 204. And then I'm going to divide everything by that negative 3 to get C equals 9 divided by 3 is 3. 204 divided by negative 3 is negative 68. Now that I have isolated this, I isolated this C here. That's what I have here. I need to plug it into my other formula. So I'm going to plug it into this formula here. So we're going to say that 2J plus 5 times, once again, I'm substituting in this C, 3J minus 68 is equal to 204. Now all we have to do is finish solving this out. I'm going to distribute. So we have 2J plus 15J minus, I'm going to do my calculator to do 68 times 5, minus 340 is equal to 204. I can combine these to give me 17J. I'm going to add that 340 to the other side to get 544. You might freak out. You might be like, I've got large numbers. That's okay. Just keep solving. Dividing by 17, I hope those divide easily. 544 divided by 17. And it does. It says that J is 32. That means that John is 32 years old. Now to finish this, however, I still have to find Claire. You can substitute J back into your first equation or your second equation. I personally like to substitute it back into the one that I created along the way that already has C isolated. So I'm going to say 3 times John's age of 32 minus 68 is going to give me Claire. Well, 3 times 32 is 96 minus 68 equals Claire. So 96 minus 68 gives us that Claire is 28 years old. So the next time you see one of these problems that sounds like a riddle dealing with people's age, just stop and take a moment, write out what it's actually saying an equation for, and you'll notice you just have a linear system to solve.